Hi, my name is Francesca Balestrieri, and this is my exam mini video 3. Meet Jane and Emma. Their mothers were childhood best friends and decided to have children at the same time. As a result, Jane and Emma have been best friends since birth. Jane and Emma want to follow in their mother's footsteps and have children at the same time so their children can be best friends as well. Before trying to get pregnant, Jane and Emma decided to go get some testing done to see if either of them had any genetic abnormalities that would impact their fertility. Jane got her test results back first and discovered that she has a chromosomal aberration that will impact her fertility. Here's a representation of Jane's affected chromosomes with the letters representing different regions of the chromosome and the period representing the centromere. If we flip the bottom chromosome so that the ends of the two chromosomes match up, we can see that the middle section of the bottom chromosome has been flipped 180 degrees. This kind of chromosomal aberration is called an inversion. Since the flipped region contains the centromere, this is a pericentric inversion. When the flipped region does not contain the centromere, it's called a paracentric inversion. Because of this inversion, the chromosomes are going to have to form an inversion loop in order to pair up during meiosis. This is a simplified representation of what this inversion loop would look like. The normal chromosome is on the top in black, and the one with the inversion is on the bottom in gray. If a crossover event were to occur between J and K, the following gametes would result. Following the red line, you get the chromatid GHI centromere JKLM. Following the green line, you get the chromatid GHKJ centromere ILM. Following the blue line, you get the chromatid GHI centromere JKHG. And following the yellow line, you get the chromatid MLKJ centromere ILM. The color the gametes are written in at the bottom correspond with the lines traced on the loop above. Out of these gametes, only the red and green ones are viable. The blue and yellow ones are not viable because they are both missing some genetic material, while the red and green gametes are viable because they are not missing any genetic material. Because of Jane's chromosomal aberration, only 50% of her gametes will be viable. Emma, on the other hand, does not have any chromosomal aberrations that will affect her fertility. Here's a representation of the same chromosomes that are affected in Jane. Flipping the bottom chromosome makes it more obvious that these two chromosomes are identical. One thing to note, however, is that if a normal chromosome has all the regions in alphabetical order, the middle section in both of these chromosomes has been flipped. We'll soon see that this does not affect Emma's fertility, however, because both of the chromosomes are identical. Since Emma's chromosomes are identical, they can pair up normally, and a crossover event between J and K would result in 4 viable gametes. Since all of Emma's gametes are viable after this crossover event, she has a higher fitness than Jane, whose pericentric inversion causes half of her gametes to be inviable after the same crossover. Because of this difference in fitness, it may be a good idea for Jane to consider IVF if she wants to have a child at the same time as Emma.